The screw modifier will allow us to take existing geometry and extrude and rotate that new geometry along a specific axis point. To access the screw modifier, go to the Modifiers tab in the Properties panel, click Add Modifier, and under Generate, select Screw from the menu. This will add the screw modifier to your existing model. Let's set things up so that we can actually use the screw modifier on an object. With our cube, I'm actually going to take a single edge here, and then I'm going to invert my selection with Control and I. I'm first of all going to select as much as possible apart from this edge, and I'm going to delete the faces, and then I'm just going to delete the excess vertices round here so that I basically have a single edge. Now I'm going to add my screw modifier to this object. So we'll add the screw modifier, and as soon as I do that, you can see that we've been able to form a cylinder with this model. So the idea here is that it can take a very simple form of geometry, such as a single edge, and it can spin that geometry around an axis point. Now, this is most similar to the spin tool that is used in edit mode. So I'm just going to hide this cube, and I'm going to create a second example in which I'm just going to deselect a couple of vertices, again, remove the vertices that are selected to give us exactly the same thing as we had just a moment ago. But now I'm going to select this geometry, and I'm going to use the spin tool located here in the tool shelf. I can then click and drag on this gizmo, and it's going to allow me to extrude and rotate geometry around a specific point, which by default is going to be the object's origin. I can then manipulate certain parameters such as the number of steps, the total angle, the ability to merge, the center point, etc. Now, many of these parameters are going to be available with the screw modifier. The key difference, of course, being that since it's a modifier, we can always come back and edit these values further along in the project. The first parameter is the angle. This represents how far around the point of origin the new geometry is going to rotate. At 360 degrees, it completes a full rotation, meeting the start point, wherever that may be. If we click and drag, we can begin to lower or even increase the angle value, and then we can rotate the geometry to whichever area we desire for our mesh. So you can click and drag in real time to define exactly how much and how far the screw modifier is going to rotate your geometry. The screw parameter will allow us to offset the revolutions of the screw modifier in a specific axis. In this case, I can click and drag on this screw value, and it's going to push the geometry up. And the more revolutions we go around the model, the further that geometry in that location is going to be moved up on the Z axis. So for example, by setting the screw value to 1, the start point is going to be set to a specific location on the Z axis, but the end point located here is going to be 1 meter higher up on the same axes. So we can manipulate the screw value of the screw modifier in either a positive or negative direction to offset the location of the newly created geometry. We then have the number of iterations. So this is the number of times the screw operation is going to be applied. It takes into account the 2 parameters directly above it, including the defined axes, which is set below, and then it will recalculate how many times it completes the action of the screw modifier using the iterations value. It's set to 1 by default. If we set it to 2, it's going to spin that geometry around again another 280 degrees. At the moment there's some overlapping, so we're going to increase the screw value to be around 1.8. So we've got a little bit of a gap in between, and now if we just zoom out, you'll be able to see for each time I complete another iteration, the geometry is going to rotate another 280 degrees, in addition to the extrusion and addition of the new geometry required to create such an effect. So we can adjust things like the angle value, and you can see how this affects the object after we have increased the number of iterations. We can also change the screw offset, which effectively creates more of a gap between the top and bottom of each iteration. And then of course we have the number of iterations themselves. When it comes to the axis, we're always going to want to choose the one that is best suited to the orientation of the original geometry. So if I was to go into edit mode here, let's just locate the original edge, which is right here. So at the moment this edge is basically vertical, which means it's going to operate best on the z-axis. Now I can change this to the y-axis, for example, and it's still going to function, but the result isn't going to be technically correct. So we've got a lot of what looks like overlapping or arching geometry here, and it's always bending in on itself, which isn't really the type of geometry that you would want for a 3D model. The same would apply here for the x-axis. Again, it kind of works, but at the same time, this isn't really going to be the sort of effect that you're looking for when using the screw modifier. So for this example, the z-axis is the correct axis to use. But let's see what happens if I begin to rotate the original geometry. So I'm going to hit the R key, and let's rotate it on the x-axis. So as I begin to rotate the initial geometry, you'll see how this reforms all of the geometry that is created using the screw modifier. And we're still using the z-axis here. So let's set that to a value of 90, for example. And now we have an iteration of geometry where it spins up, but in a very different way to what it did before. However, let's see what happens if we change the axis. So at the moment, our geometry is moving along the y-axis itself. If we were to left click this option, we'd get something similar to what we had in the first place before we rotated our geometry. And we can manipulate that with the screw, angle, and iterations. If we set this to the x-axis, again, we get a slightly different result in the way in which the screw modifier both generates and then rotates that geometry. Under the axis options, we have the ability to control our geometry based on an axis object. So if we don't actually want to move the original geometry to alter the direction or the effect of our screw modifier, we can use an axis object instead. This is typically going to be an empty. So I'm going to use a plain axes empty object. And for now, I'm just going to keep it exactly where it is. Then I'm going to reselect the cube, go to axis object and select empty. Nothing's going to change initially, but if I take my empty object, hit the G key and begin to manipulate its positioning, you can see how it manipulates how the geometry is being formed along that defined axes. So it's not changing the axis value that is set above it. So we can change to Y, for example, then select the empty and hit G. And this actually does an even better job at manipulating not only the size, but also the direction of the screw modifier. And then if we select again, we can go to the Z axis, take our empty object, press G, and again we can manipulate the positioning of the empty, and this changes the behavior of the screw modifier depending on our selected axis. Now as for object screw, this is going to add the location of our empty object as a factor when determining the height of each iteration created by the screw modifier. Currently, the location of our empty object is at 0, 0, 0. It's currently going up on the Z axis, so the Z value is most important here. I'm going to select the main model, and then I'm going to select object screw. As soon as I do that, it basically just becomes a wheel of sorts. But now I'm going to select the empty, hit G, then Z. Then as I move this up, you'll see we have control over the height of our model. So the positioning of this empty object is going to be roughly equivalent to a single iteration of the screw modifier. If I just reduce that to a value of 1 so that there's a single iteration, you can see it basically lines up in terms of the height of the object compared to the positioning of the empty on the Z axis. The next two options determine the resolution of our screw modifier in both the 3D viewport and the render. So in the 3D viewport we have 16 steps as we do the render. What this means is that when we manipulate the values above, so for the angle, screw and number of iterations, what's going to happen is it's going to create geometry in the form of additional edges that in turn become faces. And every one of these represents an additional pair of vertices that are generated. So if I set this down to a single step, it actually creates a non-manifold mesh, but effectively it's just a plane. If I set this to 2, we effectively create a few planes. As I increase the number of steps, we increase the amount of geometry that is going to be generated within the 3D viewport. So we're going to want this to be a value that is suitable for the appearance of the model. When it comes to the render option, this is how much geometry is going to be created for when we actually render the image. So you want to use a high enough value in the viewport so that you can accurately see the detail and the structure of the model, but you may want to go higher still for your render of that geometry in order to add more detail and reduce the aliasing of the sharp edges that you often see with low poly geometry. If we set the viewport steps to 8, we can see how large each phase of our screw becomes. But if we go and render this image, you'll see that there are quite a few more steps, and actually we've got some hidden geometry that's being involved here. So I'm just going to remove that hidden geometry. Let's just render that again. And you can see that there's a lot more resolution here. There are some artifacts that happen because of the way we have manipulated the screw modifier in this example. But you can see that when compared to the 3D viewport, each step is significantly smaller and there are more steps to count in the rendered version of our geometry. I'm now going to create a different example for the next tool we're going to look at, which is merging. For this, I'm going to go into my front orthographic view, and I'm just going to add a single vertex. Now this comes as part of an add-on called Extra Objects. So if you want to access it, just go to the Get Extensions section in the Preferences panel and locate Extra Mesh Objects, and this will be visible in the Add Mesh menu. So I'm just going to add that vertex. It's going to take me into edit mode for the object, and I'm just going to create a basic 2D shape. And this is just going to be a glass just to start things off. And now we have a basic shape. I'm going to demonstrate the merge functionality, what it does and what it does not do. So this may actually be slightly confusing to beginners, but when we use the screw modifier, we can activate the merge option, and this is going to merge geometry that is within a certain distance. Some users might think that this allows us to automatically merge the start and end points of the geometry that's generated. However, this is not the case. If I was to set this to 360 degrees and have the merge option turned off, I can go to apply the screw modifier, go into edit mode, select the geometry that would have had the start and end point, press G, and I would see that it has merged automatically. So you don't need to activate the merge option to combine the start and end points. You only need to ensure that you set, in this case, the angle to be 360 degrees. So what is that merge option used for? Well, I'm just going to remove the screw modifier temporarily, and the screw modifier's merge by distance focuses on the object origin, so it's going to merge the geometry that's close to the object origin point. In this example, I'm going to add a little bit more geometry to our glass. So now we've got that extra geometry, which is going to add a little bit of thickness, but perhaps most importantly, we've added one more vertex close to the blue line. So this is close to the chosen axes of the screw modifier. That means that when we add the screw modifier, initially we're going to have a small hole in this area, and we're going to use the merge tool to close that hole up. I'm going to go into object mode and add my screw modifier. If we orbit our view, we can see the hole. Now I'm going to activate the merge tool, and even with it active, the distance isn't quite high enough in this example, so we're just going to increase it just a bit until the hole disappears and the geometry merges together. To confirm this, we can go to our Viewport overlays menu and turn on wireframe. So we can see that the geometry has been joined at the center when the merge tool is active. If we untick this box, we can see the hole, and we can also see the geometry that would be generated as a result of the current settings for the screw modifier. So this is with merging turned off, and this is with merging turned on. The stretch UV options are only really required if you start off with geometry that already has at least one face, and that face is already UV unwrapped before using the screw modifier. All these two options are designed to do is prevent distortion onto the newly generated faces when the screw modifier is used to map out the new geometry. In the vast majority of cases, however, you're going to be starting how we did for this model, using a 2D plane of a very basic shape. If you'll recall, if we hide the screw modifier's effect, this is the shape that we created for this object. There are no faces, and therefore no UV mapping. That's why in a lot of cases when you use the screw modifier with this workflow, these two options are largely going to be redundant and you can normally ignore them. There is an additional section for the screw modifier labelled as normals. Here there are three options: smooth shading, calculate order, and flip. The first one is on by default, and this is smooth shading. You'll have seen this a lot if you've used Blender for any degree of time. So if I make the object visible, by default, the added geometry is going to be shaded smooth. But if you want to see those faces, you can turn this option off. And if I just turn off the wireframe, you'll now be able to see all of the geometry that is generated using the screw modifier. If you want to see it with smooth shading, you can just turn this option back on. If you have any noticeable problems with normals and shading artifacts, this one looks quite clean, but you can go to the normal section and you can tick this box for calculate order. This is just an additional step for the screw modifier that, when ticked, is going to ensure that the edges are added correctly using the screw modifier, and this is going to better prevent any issues when it comes to the shading that you may apply later on to the surface of the model. The last option is the ability to flip our normals when we apply the screw modifier. Now I'm going to leave this unticked because this is going to be a good example. I'm going to apply my screw modifier and I'm going to go into edit mode. Now you'll see I have these blue lines and they indicate the normal direction of the individual faces. If you want to know how these can be accessed, just come to the Mesh Edit Mode Overlays menu. It's this menu right here. Turn on this button for the face normals and just increase your size. Now with these normals, everything looks right, but on closer inspection, there are some faces where we can't see the normal direction, and ideally we're going to want to see the normals for all of the faces that we create. In fact, it could be that all of our normals are facing the wrong way. This doesn't look the case, but actually some of these blue lines, these normals that are pointing upwards, may actually be joined to the faces at the bottom of the glass. So you see we've got some thickness here, and you've got normals coming up and down in both directions, but they may not necessarily be for that specific face. What we can do here is we can use Ctrl-Z to undo until we get our screw modifier back. We can then choose the flip option underneath the normal section. Then we're going to apply the screw modifier and return to edit mode. This time we can see normals around the edges of our model at the bottom. If we take a look at the top, we can also see additional normals coming out of these faces along the top. So in this case, it looks like we have been able to correct the normal direction of the generated geometry from the screw modifier. And this was quite a simple shape to create. So this is one of those options that I recommend you learn to ensure that the shading is going to be correct and the normals are facing the correct direction. But that about wraps up all of the tools that you would need to know for the screw modifier. If you enjoyed this video and would like to see more, don't forget to like, subscribe and hit the notifications bell icon for more updates and tutorials related to Blender.